to show how different VMware data products work together to create a scalable streaming application that can handle fast real-time data using Spring Boot framework. We demoed the interactive app we called Twitter Word Cloud, which pulls tweets from Twitter by emergency hashtag. Basically, anytime anyone tweets anything with the hashtag emergency, we are capturing those tweets. The hashtag is configurable and can be changed to anything else. After a tweet is pulled, we break it into words and do some lexical analysis. And finally, we draw all words in our app as a word cloud, meaning the more frequent is the word, the larger it appears. We can see here RT is frequent for some reason. There's also emergency, contribute, help, and some other words. Now let me show you the architecture. On the top left, we have the Twitter we connect to with Twitter API version 2. And you need a Twitter developer account for this to get the API key, which I have. Then the Twitter microservice on the left-hand side pulls tweets by the hashtag every 15 seconds. And this can be changed to any other frequency. The Twitter microservice publishes all tweets to two targets within the same RabbitMQ cluster. So one is RabbitMQ queue, and it's used for real-time notifications in our app. And the second is RabbitMQ stream, which is used for full history. Now we have a second microservice we call the Twitter Word Cloud, which scales horizontally so that it can have multiple replicas to handle larger traffic on multiple machines and provides high availability. And each replica has a built-in web server so that we can open the browser and see the UI like we see here right now. This microservice consumes tweets from a RabbitMQ stream and saves them into a low latency cache called VMware Gemfire, providing fast real-time access to data. Most importantly, Twitter Word Cloud microservice has a very important feature, the time offset, which determines from which point in time we want to analyze captured tweets. So now we see the demo with live data within last hour. Let's quickly try to show you the full history because we have full history here in the stream and we can do the time travel. So to go back in time, we need to stop the Word Cloud microservice for a second. We need to clear the cache, clear the Gemfire. We need to change our history offset to something, let's say 1st of January, which is kind of our beginning of time. And we need to restart our Twitter Word Cloud microservice. So while we're starting, let's quickly mention that each backend product that we have, the Gemfire and RabbitMQ, is run on Kubernetes, which ensures high availability and resilience. If I can quickly flip to our Kubernetes, this is our pods. So we have the Tanzu Gemfire namespace running the Gemfire, and we have the Tanzu RabbitMQ or RabbitMQ system namespace running RabbitMQ with multiple pods highly available. Now let's get back to our microservice. It's restarted, and we can see much many more words because now we're looking into our full history since the beginning of time. And we can quickly look into our RabbitMQ stream. We got about 700 tweets all in all, and they are all displayed in here. Now this time offset feature is very useful. Since we have full history, we can replay those events as many times as we need. We can go back in time to any point in time we need. doing the time travel. This can have multiple applications in the industry, such as regression testing or surveillance systems. Now let's quickly mention the code. So it's Java, and we use here the Spring Boot framework. Spring Boot is a framework to develop cloud-first microservices which are scalable, secure out of the box, and event-driven. The framework is declarative, is using annotations, and requires minimal code to be written, so the developer's experience is fast and straightforward. For example, we're looking right now at the cache service, and caching is done via those two annotations, cacheable and cache put, onto two respective Java methods. This is highly abstract. This is very simple. This can work with multiple caches, um, and so on. So we have the project structure on our left. We have configuration. We have controllers. We have model and services. So controllers are the entry point for our HTTP request. Each controller is lean and stateless. Controllers, they call services, which are also stateless. And this is where the business logic is. Besides under utils, we've got a collection of static functions serving different purposes, such as lexical analysis and Twitter-related stuff. Because the whole application is stateless, which is one of 12-factor app principles, our Twitter workload can scale to hundreds of replicas. Now we are at the end of our presentation, and I hope you enjoyed it.